Now that we've learned how to name covalent formulas, we're going to learn how to write covalent formulas from names. In your notes, write covalent formula writing and underline it. When writing the formula from the names, use the prefixes to determine how many atoms of each element you will need. We will be using boron tribromide as our example, so write it down underneath your title. In the name, you see that boron has no prefix, which means there is only one boron atom. In the formula, you will write a capital B to represent the one boron atom. Bromide has a prefix of tri, which means there are 3 bromine atoms. So in the formula, you will write a capital B and then a lowercase r to represent bromine with a subscript of 3. Recall that subscripts are smaller and below the normal writing. Your final formula should be BBr3. Next, we're going to do some practice problems. All 3 problems will appear on the next slide. Pause the video and try all 3 in your notes. Once you have completed all 3, continue on and check your answers. All right, so for your 3 practice problems, we have them here on the board. So arsenic, in our first practice problem, arsenic trichloride, arsenic doesn't have a prefix. So remember, in our first nonmetal, if there's not a prefix, that means there's just one. So we would write AS, capital A, lowercase s, and then trichloride means that there's 3, because tri means 3 chlorine, so capital C, lowercase l, with a subscript of 3. Dinitrogen pentoxide, di, meaning we have 2, nitrogen, meaning we have a capital N, right? Nitrogen with a subscript of 2. Pent means that we have 5, like the pentagon. So then we say oxygen, because pentoxide, oxygen with a subscript of 5. Our last practice problem is tetraphosphorus decoxide. So tetra means 4, like the game Tetris, how all the blocks have 4 pieces. So we have capital P, subscript of 4, and then decoxide, dec or deca means 10, like we talked about with a decade. So then we'll write oxygen with a subscript of 10. Again, we don't reduce this down, we keep the formula as it's given in the name. Remember, if you get stuck or you need more help, feel free to rewind the video, or you can go to your book, section 23.4, page 397.
Recall that covalent bonds occur between 2 nonmetals and ionic bonds occur between a metal and a nonmetal. Also remember, hydrogen is actually a nonmetal. So when we think about covalent compounds, hydrogen would be part of that. On the next slide, there are names or formulas of 6 compounds. Before trying to complete the table, identify if they are ionic or covalent bonds. All 6 problems will appear on the next slide. Pause the video and try all 6 in your notes. Once you have completed all 6, continue on in the video and check your answer. Alright, so we're going to work through these 6 mixed problems and identify either the type of compound, name, or formula depending on the empty spaces. So let's look at the first one. So first I need to identify what type of compound it is. So I'm going to look at the name, and sodium is my first element. So if I look at my periodic table, I find sodium. It's on the left-hand side of the periodic table, so that I know sodium is going to be a nonmetal, or a metal. Then bromine, when I find bromine, it's Br, it's on the other side. So on the right-hand side, it is a nonmetal. Okay, so this is a metal and a nonmetal, which is going to make this ionic. So this is an ionic compound. Okay, then if I'm thinking of my formula, I need to keep in mind the charges that both of them form. So I suggest, as you're writing the formula out, work through the process. So sodium is in group 1 so its charge is a +1. So I know Na is +1. Bromine is in group 17, so it has a -1 charge. So Br has a -1, okay? And then I need to get those charges to cancel out and be neutral. So if I have a +1 and -1, I just need one of both of those ions. So NaBr will be my formula. On the next example, I was given the formula of NO4. So if I look on my periodic table, it's nitrogen. It's on the right-hand side of the periodic table. Oxygen, also a nonmetal, on the right-hand side. So I have two nonmetals here. Okay, so if I have two nonmetals, that's going to be a covalent compound. And then I can figure out the name. Remember, when you're naming covalent compounds, you use prefixes. So nitrogen here, I only have one of them, so it's not going to have a prefix, so I'm just going to write nitrogen. And then if I look at oxygen, I have 4 oxygens, so I'm going to use the prefix tetra. And then remember, oxygen turns into oxide, so it would be tetra oxide. So that would be my name, nitrogen tetroxide. All right, the next one, rubidium sulfide. So rubidium, I know it's not on your list of elements, but since we're just doing practice, you can look at your periodic table. It is in group 1, so it is a metal. And then sulfur is on the right-hand side, group 16, so it's a nonmetal. So if I have a metal and a nonmetal, that's going to make this an ionic compound. And then if I'm writing the formula, remember I have to consider the charges for ionic formulas. So rubidium, which is Rb, is a +1 because it's in group 1 of the periodic table. Sulfur is a -2. Okay? I have to get the charges to cancel out, so I'm actually going to need 2 rubidiums and 1 sulfur. So Rb2s. Okay, you can do this different ways. You've learned the crisscross method now, and you've also learned by showing the electron transfer. So either of those are working, or if you can just visually see that. All right, so since calcium is a metal, it's on the left-hand side of the periodic table, and nitrogen is a nonmetal on the right-hand side of the periodic table. Metal and nonmetal would be ionic. Okay, so again, we have to consider the charges. That's how we got these subscripts. When we're naming it, remember the cation will always keep its original name. There are no prefixes in ionic naming. And then nitrogen just turns into nitride, and you add that IDE ending to it. So we have calcium nitride. Okay. The next one, barium oxide. So barium's in group 2 on your periodic table, so that is a metal. And oxygen is a nonmetal. It is in group 16. So, and on the right-hand side, so it's a nonmetal. So that makes this a ionic compound. Okay, so you have to consider the charges. Ba, barium, because it's in group 2, has a +2 charge. Oxygen has a -2 charge. It's in group 16. These two charges cancel out, so the formula is just BaO. Okay, if you do use the crisscross method, just make sure that you reduce. So if you wrote down in your original problems when you worked it out as Ba2O2, you have to reduce those 2's down. So you should have BaO as your answer. All right, and then the last one, carbon, we know is on the right-hand side, so that is a nonmetal. And oxygen is also a nonmetal. So this one is a covalent compound. We've used this one as an example many times, and you've probably heard this before. So the name for it, carbon, because it has just one atom, does not have a prefix, so carbon. And then oxygen has two atoms, so we're going to use the prefix di, okay, and it would be dioxide. So carbon dioxide is the name of that last one. If you're still struggling with this, please come in, either rewind and go back through this video and the ionic video, or come talk to your IPS teacher. You can also reference the book, page 397, I believe. But I think the biggest thing you should always start with is figuring out what type of compound it is. Once you determine what type of compound it is, then you can start using the rules that you've learned in the last two videos.
So after today's video, you should be able to write formulas for covalent compounds, write the name of a covalent compound from the formula, and remember from ionics, we should be able to identify the bond type. So if it's two nonmetals, it's covalent. If it's a nonmetal and a metal, it's ionic. We should be able to write the chemical formulas and names for ionic compounds and draw the electron transfers for ionic compounds.